Welcome to Sundar's lecture. This is lecture number 29 actually. See, in this lecture, we are going to start a new topic. I've told you already, right? So, this is actually AC circuits, right? So, we have seen DC circuits up to 28th lecture, and now we will start what is AC circuits, right? So these AC circuits are commercial, they are used in commercial and domestic purpose. So what is AC circuits? What is the difference between AC circuits and DC circuits? That is what we are going to see in this lecture. See, this is the DC current. I have taken current to explain things. So this is DC current. See, in DC current, the magnitude of the current will be constant with respect to time. This is actually time. This is actually the y-axis is current and x-axis is time. You see, this magnitude of current is always constant with respect to time. So that is nothing but DC current. And if it is a AC current, you can see this waveform. Actually, this is a sinusoidal waveform. In sinusoidal waveform, you see, this is the magnitude. Actually, this is the magnitude, and this magnitude is changing with respect to time. Actually, this is time. This is time axis, and this is the current axis, which means we have taken current. Maybe it can be a voltage also, right? So you see, at this instant, at this time, the magnitude is this much, and at this time, the magnitude is the highest or peak value, and at this time again the magnitude is reducing and it comes to 0 and it is increasing in the negative direction. See, it attains the maximum negative and then again it is increasing to 0. So what is an AC or alternating quantity? Alternating quantity, which means it alter with respect to time, whereas direct current quantities, it does not change or alter with respect to time, right? So that is what we have written here. AC current and alternating current is the current which changes in magnitude and direction periodically, which means this the time taken, I will explain you bit later, the time taken to complete one full cycle. This is actually one full cycle and it will repeat periodically, it will repeat, which means the time taken to complete one cycle will be the same for all cycles. That is why we will always call these are all periodical waveforms. Periodical waveforms, right? So what are all the advantages of AC quantities or currents? See, voltage can be varied with respect to with the transformer easily if it is a AC circuit. But whereas DC, varying DC will be complex, little bit complex when compared to the AC voltages, right? High voltage transmission is possible since we can vary the voltage with the transformers. We can transmit the high voltages, right? That is also possible, and the high voltage transmissions are economical and efficient also. So AC quantities are used in commercial purpose and also in domestic purpose, right? Due to these advantages, right? So we are not going very much into this, like what is transformer or transmission, and we just want to know what is the advantages of AC over DC, right? So the next topic, next one, this is the standard form of AC, right? You see, not only this is the AC, with respect to time, whatever signals you take, if it is changing with respect to time, then obviously that is an alternating quantity. See, I will give you an example. See, we will take a circuit like this. Maybe we will draw like this. We have a circuit or we have a waveform, right? Not circuit, waveform. For example, if there is a waveform like this, see, this is magnitude, and this is time. Let us we take this is magnitude and this is time, right? See, this is also an alternating quantity. With respect to time, the magnitude is actually changing, right? So this is also AC. See, you should not assume that Only sinusoidal waveform is an AC. Actually, we will draw like this, right? We will draw like this. But this is not only AC. This is actually sinusoidal waveform. A part of AC quantity. That's all, right? This follows the sine wave. This follows the sine omega t expression. That is why we are calling this is a sinusoidal waveform. Because it is varying with respect to time, we are calling it as AC quantity. That's all. This is also AC quantity. So many students are assuming that only a sinusoidal waveform or sinusoidal quantity is an alternating quantity. No, actually this is also an AC alternating quantity. Anyhow, so we will come here. See, we have seen the advantages and see this is the standard form of AC. We will write down the expression. Maybe this is also I. I have written for V. Maybe it can be I. So V is equal to Vm sin omega t. Right. This is the, and we will see why we are writing this expression for this type of waveforms. That means sinusoidal waveforms. That I will explain separately. Before that, you try to understand what are all the terminologies that related to this expressions, right? So what is Vm? Vm is the maximum voltage, or we will call it as peak voltage. And what is this? This is sine. Since this waveform follows the sine quantity, so we are using sine omega t. And whereas what is omega and what is t? So omega is actually the angular frequency, and it will be 2 pi f, and I will explain you why this is 2 pi f. And what is t? This is with respect to time, so it is t. So sine omega t, and whereas omega is the 2 pi f angular frequency, and we can also write this f is equal to 1 by t, that is the inverse of time period. And what is time period and why we are writing it in the inverse form of frequency, all those kind of things we will see. Anyhow, a standard AC can be denoted by V is equal to Vm sin omega t, or I is equal to Im sin omega t, right? That is also possible. We just for our understanding, we have taken this expression, right? So let us take this is the waveform called, we will call it a sine wave. Maybe it is a sine wave, right? Since it follows the sinusoidal expression, which means I will write down here. See, maybe we will take this as V is equal to Vm sin omega t, and I will explain you this by using omega t value. We try to substitute the omega t values, and we will plot the graph. There you can easily understand why this waveform is coming like this. Right. Before that, we will see what are all the basic terminologies or basic quantities or basic definitions in an AC quantity. See, what is instantaneous value? See, I will explain you this graph first of all. This is the starting point 0, where it is pi, 2 pi and 3 pi, all those kind of things and all you know already, right? See, this is an AC quantity. We have drawn like this, and in the y-axis we have taken voltage or current, it may be anything, and in the x-axis we will take time, right? So our graph is like this, right? So we will see one by one. So instantaneous value. What is instantaneous value? Instantaneous value, the value of alternating quantity at a particular instant. You see, this is one instant at t1. This is actually time axis, and at t1, what is the value of this graph? This graph. You see, at t1, this is nothing but e1. This is one instant. This is one instant. See, at t2, what is the value of the e? That means I am taking it as actually t2, so I am taking it as e. It is actually in the negative direction, so I am writing it as minus e2. So what is instantaneous value? With respect to time, or with respect to with respect to time, what is the value of an alternating quantity at a particular instant? That is nothing but instantaneous value. And cycle, this is very important. Cycle, you have to understand cycle very clearly, right? See, one cycle, which is nothing but one full completion of positive and negative portion of the waveform. Why it is very important to understand cycle? Since if you see this is one cycle, which means one positive cycle, one positive portion and one negative portion, completion of these two, we will call it as one cycle, and then the same cycle will repeat periodically. That is the thing you have to understand. So what is this one cycle? The one, a positive half cycle and then a positive portion and negative portion, which is going to repeat periodically. So this is the one cycle. That is what we have written here. See, one cycle consists of 2 pi radians. See, this is 0, this is pi and this is 2 pi. Or if it is a degree, we can write it as this is 0 degree, this is 180 degree, this is 360 degree. So completion of cycle, that should be in 360 degree or it will be 2 pi radians. If you are writing in radians, then it will be 2 pi, and if you are writing in degrees, then it will be 360 degrees, right? What is time period? And if you know what is one cycle, then that will be the time taken to complete this one cycle. That is nothing but time period t. It will be always denoted by t, capital letter T, not small letter. Since small letter t, we will denote it for x-axis or maybe instantaneous values, right? So what is frequency? Frequency, which means for 1 second, per second, how many number of cycles are repeating? That is known as frequency. Number of cycles completed by the alternating quantity per second. So then F will be is equal to cycles per second. Right? You see, since you can assume that you can see that time period for one cycle, which is nothing but we can write it as seconds per cycle. How many number of seconds it is taken to complete one cycle? That is nothing but seconds per cycle, right? But you see, frequency is cycles per second. Both are inverse in nature, right? So then what we can do? F can be written as 1 by t. 1 by t. Frequency and time taken to complete one cycle will be always inverse in nature. That is what we have written here. So maximum value, what is the maximum value? See, this curve is attaining maximum at this point, is under positive portion, and you can see it is attaining the maximum point at this point under the negative portion. This is minus E max and this is positive E max. So we will write like this, or it may be EM, anything it may be, right? What is angular frequency? Angular frequency, which is nothing but it is an electrical radians per second. We know one cycle is 2 pi radians, right? So electrical radians per second is called as angular frequency per second. How many electrical radians we are getting, which is nothing but angular frequency. And what is radian? Radian, which is nothing but it is 2 pi, since one cycle is completed at the 2 pi. And what is the cycles per second? What is cycles per second? Which is nothing but it is F. So what is omega then? Omega will be is equal to 2 pi F. So what is F? We know that it is 1 by T, inverse of time. So we can also write omega is equal to 2 pi divided by T. So that is what we have written here, right? See, that is why I have told you, you will understand what is this F, T and the time period, everything, Vm. What is Vm? Vm, which is nothing but here we have written it as Em. Vmax or Vmax, both are same, right? So these are all the basic terminologies in an AC quantity. All these kind of things will help you while learning the AC quantity, or while we are going deep into the AC quantities. You go through these basic quantities and we will explain in the next class. We will see how this waveform is actually coming. Why it has to be like this? We try to substitute, instead of this omega, we try to substitute the theta values. Theta, you see, we always call omega t or theta. Both are same. I have not told you that. Anyhow, theta or t, this is the x-axis, and what is theta? That is nothing but omega t. Since omega is equal to angular frequency 2 pi. Yeah. See, so we will see the proof for this expression. We have already seen the quantities. Anyhow, we will see the proof in the next class. Thank you. Go through this.